Okay, automatic control, principles and practices. Holzek, automatic control, Digital Internet Archive 2017. Automatic principle practices. Warner G. Halsbeck, Chief Engineer, Asenic Regulatory Company, Chicago, Illinois. Ren Hood Publishing Corporation, New York. Alright, Chapter 1. The Automatic Control System. Control, loop, time, lag, speed, corrective action, stability, state, characteristics, acceleration, calibration, errors, resolution, sensitivity, deadband, linearity, hysteresis, linearity, hysteresis, control, step function, response, process, method, results, process without self-regulation, process with self-regulation, gain, response rate, time, constant, variant, definition, time, constant, processes with dead time, multiple capacities, step function, response, adjustment, control, two position action, single speed, floating action, proportional speed, floating action, proportional piston action, proportional plus reset action, plus proportional plus reset plus rate action. Chapter 5, frequency response and schedule input, phase lag, frequency magnitude ratio, technique for taking frequency response data, graphic representation, frequency data, phase lag, phase reversal, stability condition, dead time, and instability factor, combination frequency response data, block diagram, graphic addition, frequency response data, unstable components, unstable loop, proportional speed floating controller, proportional position controller, proportional reset controller, proportional reset plus brake controller, conclusion. Mechanical components, spring, diaphragm, bellows, flap, nozzle, pilot valve, jet pipes, four-way valves, cylinders. Electric components, pentameters for rheostat capacitors, induction coils, differential transformers, galvanometers, oscillators, phototypes, synchrosis, electronic magnetic amplifier, moving coil, servo motors, torque motors, balance and computing circuits, force balance, deflection system, force balance, null system, pneumatic circuits, position balance, Wheatstone bridge, computing differential transformer, measuring elements, square root extraction, temperature control, control root units, pneumatic position balance, pneumatic control of force balance, hydraulic controls, electronic controllers, interaction. 11. Final control element. Force the spring opposed with the diaphragm valve. Stroke time, spring opposed diaphragm valve. Valve position, valve characteristics. Regainability. Process gain, collision valve action, controlled loop. Other control valves, actuators. Control system 12. Average control cascaded control ratio. Control 2 to 3 element control. Totalizing time schedule control. And in 13, industrial applications, steam generation, soak pit, water treatment, air conditioning, solvent recovery, gasoline production index. Alright, Chapter 1. The automatic control system. With a few exemptions, these were pointed out with the text file with the terminology prepared with the American Society of Mechanical Engineers, published in 1 Standard 105 107 with the definition of the track for these standards made with the permission of the publisher. The control elements for the automatic control system combined in a closed loop, illustrated in Figure 1 with the measuring means automatically. Reference, input, set point, actuating signal, automatic controller, controller output signal, final control element, manipulated variable, process, load changes, control variability, measuring means, primary feedback. Control over the final control element with the considered separate units. If there is agreement, the common unit differs from the American Society of Mechanical Engineer terminology, that combines all 3 units for the term automatic control and leaves no term for the designated unit, but generally known as for the controller proper. Input automatic control is the actuating signal, which is the difference between any time between the reference input and the primary feedback, with the difference is obtained with a component called the summing point, which is symbolized by a circle illustration. Summing point is generally the part of the control of the primary feedback. It's the magnitude of the controlled variable as interpreted by measuring means. Hence, for the actuation signal code can also be defined with the deviation control variable from the set point. The automatic control system included with the process. More specifically, however, the control system may be considered with a combination measuring mean with the control of the final controlled element, disregarding the process. Thus, in speaking with the hardware of the control system, process elements of the light, cracking towers, evaporators, etc., are usually excluded. The purpose of the automatic controller is to reduce the actuating signal to a minimum, preferably to eliminate with the least delay possible. But the means of effect for the controller output signal, which for the transmit of the final control element, they may be valve upon any other device which directly chain with the value of the manipulated variable. The manipulated variable is a condition of the characteristic of the control agent. For example, the full control element changes with the fuel gas flow from to a burner. Manipulated variable is flow, and the control agent is fuel gas. The control fuel is the condition character of the control medium. For example, where the temperature of the water is in the tank is automatically controlled with the control variable is the temperature of the controlled medium, such for the heat utilized with the transform primary with the element to produce the effect with the function of the change in value with the control variable. The effect with the produced by the primary element may be changed with the pressure, force, position, electronic potential, or the resistance. Primary element, a proportion measuring mean that consists of those elements involved with the assertion communicating in the summing point with the control valve of the control variable, single to which the measuring mean for the transmit with the summing point with the primary feedback is compared with the reference of the input signal with the return and determine a set point. Set point is a position which the control point setting mechanism is fixed. The automatic control point possesses a set point scale. Set point on the scale reading translated into units for the control variable with a set scale that is not provided with the set point is in position with the control point setting mechanism translated into units of the control variable. The set point with a varied manually over the automatically time schedule with a ratio control system. Sometimes an automatic control, for example, these two position differential gap floating action neutral zone set point is related with the position range value of the control variable. Set point is often selected for the center range of the values. A permanent deviation of the control variable from the set point is called an offset. It is convenient to speak of the value for which the controller is adjusted set point with the value of the controller mean with the automatic as a control point. Control point is the set point plus or minus offset. Disturbance is called load changes entering the process of representative of the variable. The requirements of it requires adjustment by the controller. Without load, the chain with the control system just as well with the manual, since once it is now set, no changes will take place. Load changes have various costs for the show for the reboiler into the which the process fluid into the condensate with the brought into a boiler by shows the process fluid condensation steam line in process fluid vapor temperature control primary element. That's a reboiler. So condensation in, steam in, condensation out, process fluid for condensated, temperature control primary element, processing fluid vapor. A steam heat exchange with the process fluid leave with the reboil, the vapor level, the control of the line indicating maintains the level of the vapor temperature for the control variable, the steam flow with the manipulated variable, the load chain with the process effect with the temperature with the E entering with the process fluid, B the step steam temperature, C with the steam pressure with the reflective of the rate, flow chain with the given valve opening, condensation with the temperature outside with the temperature for the draft cooling, etc. And in addition to those low, there are long range but not less important changes like scaling with the tube, deterioration, heat insulation, etc. Time lags. If action and reaction control system were to take place without loss of time, no control problem would exist. For example, the steam production with the boiler operation under the sum of the ideal conditions would increase slightly. The slightest drop in the steam pressure balance with the condition would restore immediately without difficulty. With the balance condition required with the input steam with the producing elements corresponding with steam output is required by the load. Practically for the circumstance due to the time interval between the output range necessary corrections taking the effect of these corrections. First delay occurs due to the fact that the load change is not sensed immediately after the result of the change with the control variable. The steam pressure for the above of the example of the speed with the control system was intended to keep the control variable constant. It is built on the premise of the control variable changes before corrective action takes place for the unavoidable contradiction inherent in all automatic control systems. The art is keeping the change with a minimum. For example, the control variable is to be kept at 1 plus or minus 1% of the set point value. It's necessary with a much smaller change than suffice in initiative corrective action. The next day delay occurs converting controlling output signal into the chain with a magnitude value with a bold means of the final control element. Frequently, the most serious delay is due to the time loss of the process before a control variable to respond. The two main causes produce these delay: resistance and capacitances. Resistance is the opposition of flow of the expressed with the units of the potential change of the required for the produce the unit change flow rate. For example, the flow heat with a machine with a wire through with the tubes over the heat change with a delay because of the thermal resistance caused by the scales of gaseous film, etc. Thermal resistance is the temperature differential for the degree of the Fahrenheit required to produce the heat flow rate by 1 BTU per hour through given body. Fluid resistance is the psi fluid pressure differential required to produce a fluid flow rate of 1 cubic feet a minute through a given passage. Electrical resistance is the voltage necessary to produce the current in 1 amp or 1 coulomb through the conductor. Capacitancy. Chain with the quantity with the contained with a per unit chain with a reference variable. For example, the speed with which the liquid level the tank chain with it depends on the chain with the volume of the stored liquid per unit change with the head. If the tank level drops 1 foot, 1 cubic feet, 20 cubic feet of the liquid are removed, the capacitancy is 20 cubic feet or 20 square feet, which is equivalent to the area of liquid surface of the shape as with the tank, the color of the liquid surface, the area of the vary. Change with the head capacity will likewise vary with the head. In controlling with the pressure with a gas-filled tank with the capacity may be the expressed function of weight or gas. This case capacity is charged weight stored gas per unit change of the pressure. Most typical capacity process with a flywheel. All capacities act like flywheels, which are storing up energy producing rapidly response to change. Thermal capacity is a BTU absorbed by a body to degree Fahrenheit rise temperature. Volume capacity of the cubic feet with the solid liquids that can be absorbed with a container per foot increase in increase of level. In case of the gases stand with the cubic feet psi per change. Weight capacity of the pounds of solid with the liquids that can be stored with the container per foot with an increase of level. In the case of the gases in standard cubic feet under standard condition the psi pressure change. Electrical capacity chain with electrical charge with the capacitor expressed with a microfarad volt across the terminals. Capacitance produced delay with the expressed time constant with the discover the greater detail further below. In addition, with the time constant with the delay exists between the two related actions and with the control loop. This is called dead time. Capacity produced with the delay which expressed in time constant, which is discussed greater below. Further, in addition, time constant. A delay exists between two related actions in a control loop. This is called dead time. Figure 113 shows the pH control system control for the regulates chemical with the maintains pH of the main flow before the graphic action control valve reaches the pH measurement means. pH over the control valve of the fluid over the floor, the pH control valve length with the travel of the pH and the fluid in and out. Some finite lapses of the function of the length of the travels of the less of the dead time plans for the important part of the stability of the system will be shown with the paramount with the control system. Dead time may be kept as low as possible. Speed corrective action. With the correction act for the system, time lags which will be just enough to bring the system back to the control point after the load change for the action would be slow. But the control variable will continue the chain with the meantime close control with the remaining possible majority of the cases. On the other hand, to intensify corrective action after the load with the chain with examples with adjusting more fuel for the process of the actually necessary in order to gain the faster action process procedures. Processing actual necessary within the order of the given faster action produced for the overshooting one with the control variable, the pressure for the back for the control point with the excess of fuel emission result of the overcorrection chain with the pressure in the direction opposite with the initial deviation of the resulting control action will now produce undershooting oscillation around the control point are the result. Shows control variable excessive stability slow, accessibility response usually best solution control variable. Then it shows control variable extensive instability, and these are in time ratios. The entire problem of the automatic control center with the maintained control system acceptable stability conditions will attain with the greatest possibility speed with corrective action stability. Figure 1.4 shows the various forms of the response with the control variable sudden change. Set point with the control variable may be pressure level of the head with the temperature shape of the response with the curve expressed with the stability of the system. The curve A with the new value with approach without overshoot with the how with the conserve with the time elapsed until with the reaching with the new value with the curve B with the response with the conservation fast with the fewer rapidly with a subsiding oscillation. They are usually with acceptance with the form or response with the generally considered the most desirable for the curve C with the response with the almost continuous oscillation. General should respond with not accessible oscillation. However, occasionally, the oscillation provided that they are within limited amplitude, but it can be tolerated when the tough of the case of the discontinue with control of the described with a later chapter with the wood. Probably give satisfactory economic solutions. Chapter 2: Static characteristics.